Welcome back, class, for day 7 of digital learning. Yesterday, we learned how to use our technology to help us find the 5-number summary and how to use that 5-number summary to help us create box and whisker plots. Today, we're going to take it a step further and we're going to learn how to interpret box and whisker plots using shape, center, and spread. So, shape, center, and spread are all words that describe what a particular graph looks like. This applies to all representations of data, and we'll look at how shape, center, and spread look in other representations, but today we're going to look at specifically how they apply to box and whisker plots. So the first thing I want to talk about is, what does center and spread mean? So when looking at the distribution of data projected on a box and whisker plot, the center of the data is exactly what it sounds like. It tells us the center or the middle of the data. The two measures of center that we use are median and mean. The median is used to find the center when the data is symmetrical on a box and whisker plot, and the mean is used when the data is skewed. So what we need to remember here is that mean when it's skewed, and we use median when it's symmetrical. And we're going to talk a little bit more about what it means to be skewed or symmetrical when we talk about shape here in just a moment. But for right now, what we need to remember is that we use mean when it's skewed and median when it is symmetrical. Next, we'll talk about spread. So in statistics, spread, which is also known as variability, is the extent to which a distribution is stretched or squeezed. Common example of measures of spread that we use are range and interquartile range. So let's look at this model that we have. As you can see, I've broken each section up and labeled it 25%. That's because each whisker contains 25% of our data, meaning that if there were 16 people surveyed to create this data, 4 of that 16 would be found in this whisker. 4 would be found in the first half of the box, 4 would be found in the second half of our box, and 4 would be found in the last whisker. So 25% of our data is contained in each section. Just like each whisker contains 25% of the data, each half of the box contains 25% of the data, meaning that the whole box represents the middle 50%. And if you remember, our definition for interquartile range is the middle 50% of the data. So our IQR is represented by the box itself and contains 50% of our data, right? And both the IQR and the range describe variability amongst the data. Let's look at this example, okay? It gives us a box and whisker plot and ask us what percentage of sophomores watch TV for at least 15 minutes per night. Now it says at least 15 minutes per night. That means more than 15 minutes of TV, right? So let's look at our model. 15, I can identify that as my Q1. That means that 25% of my data comes before 15 or is less than 15, or 25% of the students are watching TV for less than 15 minutes. I know that in the first half of my box, I have 25% of my data. In the second half, I have another 25% of my data, and my whisker also contains 25% of my data. So 25% is above 15. So this 25 is watching for more than 15 minutes. This 25% of my data is also watching more than 15 minutes, and so is this. So 25 plus 25 plus 25 means that 75% of these students are watching TV for at least 15 minutes a night, or more than 15 minutes a night. And only 25% are watching for 15 minutes or less a night. Let's look at our next example. This one asks us a variety of questions regarding center and spread. So let's look at our first example. What is the cost of the upper quartile? Well, I know that on a box and whisker plot, my minimum ends my first whisker. My lower quartile, or my Q1, begins my box. My median cuts my box and also represents my second quartile. My upper quartile, which is what we're being asked about, ends my box, and my maximum ends my whisker on the right. So it says, what is the cost of the upper quartile? So the Q3, what is our Q3? Well, if I go down, looks like our Q3 is $26. Next, it asks us, what is the range? So if you remember, range is our maximum value minus our minimum value. In this case, our maximum value is represented at 29, and our minimum value at 7. So to find our range, we would subtract 7 from 29 to get a range of $22. Our next question is asking us about a measure of center, the median. The median is represented by the line cutting our box, and it falls right between 20 and 21. So what dollar amount is between $20 and $21? $20.50 would fall between $20 and $21. D, which cost represents the 100th percentile? So if 25% of my data is found between my minimum and my lower quartile would represent the 25th percentile. My median would represent the 50th percentile. My Q3 would represent my 75th percentile. And the only way to be in the 100th percentile is to be the maximum value. So whenever something asks you for the 100th percentile, it's asking you for the max. And our max is $29. Question E asks us, how many CDs cost between $14.50 and $26? So between $14.50, I'm going to clean up our table here a little bit. So between $14.50 and $26. Well, guys, it's asking us what percent of my CDs fall within my inner quartile range, because 26 is my Q3 and 14.5 is my Q1. So what percentage of our data falls in the inner quartile range? Well, I know that there's 25% in the first half of the box and 25% in the second half of the box. So the inner quartile range as a whole would equal 50% of my data, or the middle 50%. If we go back up, we can see that the box as a whole represents the middle 50% of the data, and that's also called the inner quartile range. Our last question says, how many CDs, or what percentage of CDs, cost less than $14.50? So $14.50 was our Q1. So what percentage is less than that, or to the left? Well, 25% is to the left, and 75% would be to the right. So how many CDs cost less than $14.50? 25% of the CDs.